Hello everyone, welcome to the very next lecture of Python programming course. I hope you all are doing well and you have completed all the practice problems from the previous lecture. In the previous lecture, we learned how to make decisions, we explored comparison operators, we used statements like if, elif and else to solve decision making problems. In this very next lecture, we are going to explore another aspects of Python, which is loops. So today we are going to solve another problem in Python. Let me ask you a simple question. What if I ask you to print hello 100 times? One option is to write print statement 100 times, but is it a smart solution? Definitely no. Imagine writing the same line of code for hundreds or thousands of times. It would take a lot of time, and it will increase the size of program as well. As programmers, we always try to find a smarter and more efficient way to solve problems. That's where the loops come in the picture. So a loop is a programming structure that allow us to execute a block of code repeatedly until a specified condition is met. In simple words, a loop means doing the same task again and again without writing the same code in multiple times. Instead of copying and pasting code repeatedly, we write it once and tell Python how many times to repeat it or until what condition it should execute. For example, imagine you are climbing to the third floor of a building. You don't invent a way to climb every step. You go from step 1, then 2, then 3, and then until the last step is reached. You repeat the same action. You lift your foot, place it on the next step, and repeat. This repeated action is similar to how loops work in programming. Now, why do we need loops? Suppose I ask Python to print welcome to Python 100 times. Without loops, we have to use the print statement and copy paste it 200 times. This approach is inefficient because it takes more time to write. The programmer becomes unnecessarily long. It's harder to read and maintain. But if we need to change that statement, we need to edit many lines. Using a loop, we write the code only once and let Python repeat it automatically. Advantages of using loops are: firstly, it reduces code repetition. Then it also saves time. It's easier to maintain. Now let's look at how does a loop work. Firstly, we will start a program. Then we initiate a variable. After initiating the variable, this is our starting block. Then the Python checks the condition. And again, after checking condition, we have two outcomes. Either the condition is true or it is false. If the condition is true, we execute our program. After executing the block, Python updates the variable. Then it goes back and check condition, and the cycle repeats until the condition is false. Now in Python we have two type of loops. Firstly we have the while loop, and then we also have for loop. Firstly, let's learn about while loop. While loop is used when we don't know exactly how many times the loop should run. The loop continues as long as the condition remains true. Continues as long as the condition is true. Then we have the for loop. For loop is used when we know how many times we want to repeat a task, or when we want to iterate over a sequence like numbers, strings or lists. We know how many times to repeat the task. Then we have infinite loop. So what is an infinite loop? As per the name, infinite loop is a never-ending loop. Why? It never stops because the condition never becomes false. In never-ending loop, because condition never becomes false. For example, I define a program, that is, write a program to print hello, and our condition is our variable should be greater than 0, and if I pass a positive variable here, the condition will always become true, so the loop will goes up to infinity. So this was all the theory about loop. In the very next section we will start with the while loop. In the previous part we learned what loops are and why they are important. We saw that loops help us repeat the same task multiple times without writing the same code again and again. Now it's time to learn our first loop in Python, the while loop. The while loop is one of the simplest and the most commonly used loops. It repeats a block of code as long as the given condition remains true. A while loop repeatedly executes a block of code as long as its condition evaluates to true. Think of while loop like someone keep doing these tasks while the condition is true. The moment the condition becomes false, the loop stops automatically. For example, we can take an example of filling a water tank. The first step is the tank is not full. Tank not full. If there is a yes, then fill water. Then check again. tank full, and if the answer is yes, then we stop the loop. You keep filling water while the tank is not full. Every few moments you check the tank. As soon as it becomes full, you stop filling it. This is exactly how while loop works. Now we will look at the syntax of while loop. Firstly, we write while. Then we define our condition, and semicolon, and then statement. This keyword tells Python that we are starting a loop. Condition is checked for every iteration. It can be any expression that returns true or false. And statement. If the condition is true, Python executes the statements inside the loop. Every while loop has three important essential components. First one is initialization. Second one is condition. And the third one is update. Initialization means giving a starting value. For example, if I write count is equals to 1, this is a starting value. The condition tells Python whether loop should continue or stop. If the condition is true, the loop runs, and if it false, the loop ends. And the last is update. Update changes the value of variable after each iteration. Change value of a variable after each iteration. This is very important because it helps the condition eventually becomes false. Without an update, the loop may never stop. Now we have understood how the while loop works and the three important components that every while loop needs: initialization, condition, and update. But Python also provides another powerful loop called for loop. Unlike the while loop, the for loop is usually used when we already know how many times we want to repeat a task, or when we want to go through a sequence like numbers, strings, or lists. In the next part, we will explore the for loop and learn how the range function makes looping much simpler. In the previous part, we learned about while loop. We saw that while loop keeps running as long as the condition is true. But many times we already know how many times we want to repeat a task. For example, print hello 10 times. In such conditions, using a for loop is simpler and more convenient. Let's understand how it works. Now, what is a for loop? A for loop is used to repeat a block of code a fixed number of times or go through each item in a sequence. In simple words, whenever we already know how many times we want to repeat something, we generally use a for loop. Imagine a teacher taking attendance. A teacher starts from roll number 1 and continues until the roll number 40. Since the number of students is already known, this is a perfect example of for loop. Now, we will see what is the difference between a for loop and a while loop. Here we have our while loop. We have our for loop. So the while loop is used when repetitions are not known. But in the case of for loop, we know how many repetitions are going to occur. In while loop is controlled by a condition. While a for loop is controlled by a sequence. While loop needs initialization and update. While in case of for loop, range handles counting. So this is the primary differences between for and while loop. Now let's quickly look at the syntax of for loop. Firstly, we write for, then we write our variable, then in, then range function, then our semicolons, and then we write the statement. For starts the loop. Variable stores the current value during each repetition. And now then we have range function. This form starts from 0 and stops before the given number. If we look at the range function, it has three forms. First, we have range first form. In the first form, say I write range, then I write 5. This means the counting starts from 0, 1, 2, 3 and 4. 5 is not included because we always exclude the stopping value. Then we have the second form of range function. In the second form, we define the start and stop. It's like a range, start, then stop. For example, I write range 1, 6. This means starts from 1, 1, 2, 3, 4 and 5. Always remember, the start is included and stop is excluded. After that we have our third form of range. In the third form we have a third element here with start, stop. We also have step. The third value is called step size. It tells Python how much to increase after each iteration. Say I write range 2, 11 and 2. So it says starts from 2, stop at 11 and create a step size of 2. So 2 plus 2 is 4, again plus 2 is 6, then plus 2 8, then plus 2 10. So it stops at 10 because the next value is 12, which is greater than 11. We can also do reverse counting. For example, I write range 10, 0 and minus 1. So it starts from 10, then have a step of minus 1, which is 10 minus 1, 9, 8, 7, 6, 5, 4, 3, 2 and lastly 1. So the for loop automatically takes one value at a time from the range. When there is no more values left, the loop automatically stops. In a while loop, we have to manage initialization, condition and update ourselves. In a for loop, the range function automatically handles the counting, making the code shorter and less prone to errors. Now we have learned how to use the for loop and the powerful range function to repeat tasks efficiently. But what if we need a loop inside another loop? For example, printing patterns like squares, rectangles or multiplication tables. To solve such problems, Python allows us to use nested loops, which we will see in the next part of this video. So far we have learned two types of loops, while loop and for loop. Both helps us repeat a block of code. But sometimes repeating one task isn't enough. We may need to repeat another task inside first one. This is where nested loops are used. So nested loop is a loop written inside another loop. The outer loops run first, and for every iteration of the outer loop, the inner loop runs completely. After inner loop finishes, the second iteration of outer loops continues. For example, take example of a class. There is a class S and it has 3 rows. Row 1, 2 and 3. These are rows. And in each row, there are 3 students. First row has 3 students. Second row has 3 students. And third row has 3 students as well. And now a teacher wants to check their notebooks. So what will teacher do? Firstly, he will go to the first row and then check the notebook of first student, then second, then third. After the first row is completed, then he will move to the second row and repeat the same thing. And then he moves to the third row and repeat the same thing. So here the rows are playing the role of outer loop and the students are inner loop, because when he goes to the first row, he starts the iteration of the first loop, outer loop, and after the completion of the inner loop, which is the counting of total students, it moves to the another iteration, which is row number 2. Now we will look at the syntax of the nested loops. For nested loop, we write our outer loop first. This is our outer loop. For outer in range, and inside the outer loop, we write our inner loop, which is for inner in range, and inside inner we write the statement. Outer loop controls how many times the entire process repeats. Controls how many times entire process repeats. While the inner loop controls the inner loop runs completely for each iteration of outer loop. When the outer loop start its first iteration, the inner loop runs from beginning to end. Only after the inner loop finishes does the outer loop move to its second iteration. So the execution flow looks something like this. Firstly, we start the program. After the starting, the outer loop starts as soon as the program is started. After outer loop, the inner loop starts. Then the inner loop goes through his iterations, and inner loop ends. And as soon as the inner loop ends, the outer loop starts its second iteration. Outer loop continues. Then inner loop starts again, and the loop undergoes until the condition of outer loop becomes false, and then the program finally ends. The inner loop finishes completely every single time before the outer loop moves forward. Now the question is, where are nested loops used? Mainly they are used in pattern printing, multiplication tables and matrix operations. Now we are done with the outer loops. However, there are situations where we don't know how a loop runs normally. Sometimes we want to stop a loop immediately, skip a particular part, or leave a placeholder for future code. Python provides 3 special statements for these situations, that is break, continue and pass. In the final theory part of this lecture, we will understand each of these statements, see how they differ, learn where they are used in real-world programming. So far we have learned how loops repeat a block of code again and again. But what if we want to change the normal behavior of loop? For example, stop the loop immediately, skip only one iteration, leave a block empty for now. Python provides 3 special statements for these situations: break, continue and pass. These are called loop control statements. Firstly, we will start with the break statement. So a break statement immediately terminates the loop. Immediately terminates the loop and transfer control to the first statement after the loop. Imagine you are working in an office. Suddenly the fire alarm rings. Do you finish all your work first? No. You immediately leave the building. This is exactly what break statement does. It exits the loop immediately. As soon as Python encounters a break, the loop ends immediately, even if more iterations were remaining. Break is used for searching for an item, password verification, ATM pin check, etc. Next, we have continue statement. Continue statement skips the current iteration and moves directly to the next iteration of the loop. Imagine you're writing an exam. You don't know the answer to the question 3. Instead of stopping the exam, you skip it and move to question 4. Later you can come back to it. This is how continue works. It skips only the current iteration. The flowchart of continue statement looks like, firstly, in the loop, we have a condition. Then, unlike break, the loop does not end. It simply skips one iteration. And then it moves to the next iteration. Now continues is used in ignoring valid data, skipping absent students, ignoring blank lines, filtering unwanted values, and data cleaning. After break and continue, we have pass statement. The pass statement does nothing. It is used as a placeholder when a statement is required but no code has been written yet. Does nothing. Used as a placeholder when a statement is required. But no code has been written. Imagine you are reserving seat for someone who hasn't arrived yet. The seat is empty now, but it has a purpose in the future. Similarly, pass allow us to leave a block empty without causing an error. Python does not allow an empty block after statements like if, for, and while. When defining a function or a class, if you haven't written the code yet, you can temporarily use pass. If I want to summarize all these statements, break stops loop immediately. Then continue. Skips the current iteration and continues. And then pass does nothing. Act as a placeholder. So we have completed all the theory for loops in Python. We have now understood what loops are, the while loop, the for loop, and the range function, nested loops, break, continue, and pass. But programming is by only writing code, not just by understanding concepts. So now let's switch to Jupyter Notebook, where we will implement every concept with practical programs. Welcome back. We have completed the theory of while loop. Now it's time to see it in action. Remember, every while loop has three important parts: initialization, condition, and update. As we write each program, try to identify these parts yourself. For the first program of the day, what we are going to do, we are going to print numbers from 1 to 10. Print numbers from 1 to 10. Firstly, the very first part is initialization part. So we will initialize our variable, which is count equals to 1. Then we will start our while loop. While then after writing while we will define our condition, which is count less than equals to 10. This is our condition. After the condition, we are going to write our statement, which is print. What we want to do, we want to print the count, and then we will update the count. In update, what we will do, we will increase the value of count by 1 plus is equals to 1. Now we will run the code, shift plus enter. So here we can see we have all the numbers from 1 to 10 written. So what does this do? When the while loop starts, it checks the condition. Initially the count is equals to 1, which is less than 10. So it prints 1. Then it moves to update. It moves the count to plus 1, which is 1 plus 1, which is 2. Then it goes up to while loop again and repeats until the value is equal to 10. The next program which we have is print even numbers from 2 to 20. They're going to print even numbers from 2 to 20. Similarly, we will define our initialization condition. Here, the count will be equals to 2 because the counting is starting from 2. Now, while our condition is count less than equals to 20, then we will print count, and in update statement, we will increase the value of count by 2. Okay, so this is our final program. Shift plus enter. So here you can see we have numbers from 2 to 20 which are even. In the similar way, we can also print odd numbers from 1 to 19. Copy paste. Okay. For odd numbers, we will write the same program. The only change which we want to do is we will change the initialized condition from 2 to 1 and then we will shift plus enter. Here you can see we have numbers from 1 to 19 which are odd. The next traditional problem of while loop is which we have is reverse counting. What we are going to do, we are going to print number from 10 to 1. For that, first we will initialize our count variable which is 10. Then we will start the while count. Here the count is greater than or equal to 1. Till the count is greater than or equal to 1, we are going to print count, and in the update condition what we are going to do, we are going to decrease the value by 1 minus equals to 1. Shift plus enter. So here we have the reverse counting from 10 to 1. Now we are going to some more complex problems. Now what we are going to do, we are going to print the multiplication table of any number which we will take as input from the user. So what we are going to do, the problem is called multiplication table. Firstly, we will take a number input from the user. Enter the number. Then we will define our starting condition, which is count equals to 1. This is our initialization condition. Then we will start with the while loop. Our condition is while count is less than equal to 10. We are going to print number, then multiply, then count, which is equals to number multiplied by count. So number by multiplied by count is the value which comes after multiplication. And in the update condition, we are going to increase the value by 1. Now we are going to print. Okay, so let's say 5. So now here we have the multiplication table of 5 from 1 to 10. We can also take example of any other number, say 22. This is, now we have the multiplication table of 22. Moving to the next problem, which is sum of first 10 natural numbers. So here we have to print the sum of first 10 natural numbers. Okay, firstly, we will define two initialization condition, which is count equals to 1 and total, which is 0 for now. Now, what we will do, we are going to store our values in total by adding it. So we will start our while loop while our condition is count less than equal to 10. Since we are going to print the sum of first 10 natural numbers. What we are going to do in the total, we are going to add the values. And after that, in update, we are going to increase the value of count by 1. So what is happening here? If, for example, for first, the value of total is 0 and count is 1. The count is 1, total plus equals to count. The count is 1, then the plus equals to 1, 0 plus equals to 1, total becomes 1. And the value of count updates to 2. Then again, loop continues and each value of count adds to the total. And at last, we are going to print these values. So we are not writing the print statement in the loop because in the loop we are only going to store the value. We are not going to print value using loop. Here you can see we have the sum which is equal to 55. So next problem is factorial of a number. If you guys not know about factorial, you must have heard about factorial in the your 12th or 11th standard. Factorial. First, we will take input from the user. Int. Enter number. After that, we are going to define our two variables. One is factorial, which is equals to 1, and count, which is equals to 1. Now, this factorial problem is similar to this sum problem. What we are going to do, we just have to make few changes here. In the while condition, we are going to put count should be less than or equal to number, which we are taking as an input. And we are going to multiply these values in the factorial value. And then in the update, we are going to increase the value by 1. And at last, we are going to print the factorial. Say, I want to check the factorial of 5. So there is a problem in the code. Let me check what it is. So it says factorial is not defined. Here, factorial of 5, which is equals to 120. Because 5 multiplied by 4 multiplied by 3 multiplied by 2 equals to 120. So we have written several programs using the while loop. By practicing these examples, you have seen how initialization, condition, and update work. In the next practical session, we will learn about for loops. Previous section, we learned how to use while loop. And in this session, what we are going to do, we are going to explore for loops. As we proceed with the for loops, I advise you to please closely look at the range function. So first, what we are going to do, we are going to solve the same problems which we solved in the while loop section, but now we will solve these problems using for loop. So the very first program which we have is print numbers from 1 to 10. In the for loop, we don't need any initialization condition. So we will start from writing for. We will define our variable which is I in range. Now we want to print numbers from 1 to 10. So the counting starts from 1 and the stopping condition will be 11 because the stopping condition is always excluded. After that, we will write our statement which is print I, shift and shift plus enter. So here you can see we have counting from 1 to 10. The next program is print even numbers from 2 to 20. Print even numbers from 2 to 20. Similarly, we will define the variable for I in range. Now the counting will start from 2 and the stopping condition is 21 because we want to print 20. And in the third section, we will write the step, which is we want to print even numbers, means the numbers should increase by 2. So in the step, we will write 2. Then we will print I. So now we have numbers from 2 to 20. If we want to print odd numbers from 1 to 19, we will write the exact same code and we will just change the starting condition, which is 2. We will change it to 1. In the stopping condition, we will change it to 20. So here you can see we have odd numbers from 1 to 19. The next program which we have is reverse counting. We will start our for loop for I in range. The starting condition, the counting should start from 10 and it should goes up to 1. So in the stopping condition, I will write 0. Now the values are decreasing by 1. So our step, in the step section, we will write -1. After that, we will print. So here we have numbers from 10 to 1. Now next, we are going to print the multiplication table using for loop. Firstly, we will take input from the user number equals to int input, enter the number. Then we will define the condition using for loop for I in range 1 to 11 because we are going to print the multiplication table up to 10. Print. Here we will use the f string. F string starts and this we will write number plus variable which is I is equals to number multiplied by I. I will print them. Say I want to get the multiplication table of 5. Enter. Here we have the multiplication table of 5 with us using for loops. Moving to the next problem, which is sum of first 10 natural numbers. Firstly, we will define our variable total, which is equals to 0. And then we will fill the values in total using for loop for I in range 1 to 11. Since 10 is included and 11 is excluded here, total plus equals to I. This will store the values of I in total by following addition. And after storing, we will print these values. Print total. See, we have 55 here, which is similar to the problem which we have solved using while loop here. Now for the last problem, we are going to get the factorial of a number using for loops. For that, again, we will take input from the user first. Number equals to int input, enter the number. After that, we will define the variable factorial, which is initially equals to 1. Then we will start the for loop for I in range 1, comma, number plus 1. Here I wrote number plus 1 because we want to include the number which we are going to take input. And number plus 1 means exclude the value which is after the number. For example, if my number is 10, the range is 1 to 11. Then what we are going to do, we are going to multiply each number in factorial. Multiply equals to I. And then we are going to print it. Print factorial. Say I want to check the factorial of 5, 120, which is absolutely correct. So we have learned how to use the for loop with the different forms of range. We have also seen the for loop can iterate through strings, making it even more powerful. In the practical session, we will combine loops by learning nested loops and use them to create different patterns and as rectangles, triangles, and number patterns. Like in the previous section, we learned how to use for loop. Now we will combine two loops together to solve more interesting problems. Remember from the theory, the outer loop controls the rows and the inner loop controls the columns or number of items printed in each row. As we solve these programs, try to identify which loop is outer loop and which is the inner. The very first program which we are going to do is print rectangle pattern. So as we know, rectangle has two dimensions, length and width. We will define the length of the rectangle by rows, columns, and number of columns will be equals to the length of the rectangle and number of rows equals to the width of the rectangle. Firstly, say I want to create a rectangle which has 4 rows and 5 columns. Firstly, we will print our first row. Firstly, we are going to start with our outer loop. The outer loop will print first row. Then after completing first row, it will print the second row, then third, then fourth. For I in range rows. For each row, what I'm going to do is for each row, I'm going to create another inner loop, another loop which is which will be our inner loop, which will print the columns, which are 5. In the inner outer loop, I'm going to define an inner loop. For j in range columns, what we are going to do, we are going to print and we are going to print our star. And after that, after printing start, what I'm going to do, I'm going to come out of the outer inner loop and I will move to the next line. And then the outer loop will continue till the value becomes 4. I will print. Now here you can see our pattern is printed, but these are not in the same line. For that, what we will do, we will write end is equals to this space. Now we have a rectangle which has 4 rows and 5 columns. This end keeps the output on the same line with a space after each star. The next pattern which you are going to print is the square pattern. The code of the square pattern is exactly similar to the rectangle since every square is a rectangle. Print square pattern. For that, we will define our variable which is size which is equals to 5. We will start the outer loop which is for I in range size. For j which is our input in range again size. We are going to print the same thing. Right? So here we have a square size 5. In the next problem, we are going to create a right-handed rectangle. Right angle triangle. Firstly, we will define the rows, which is equals to 5. And we will start with our outer loop, which is for I in range. Here, the range is from 1 to rows plus 1. And for j in range I. So the first row will print first star, the second row will print 2 star, and the third row will print 3 stars. The number of stars depends on the current row number. So whatever is my row number is my count of stars. That's why I used I in the range function. We are going to print the stars. Print star equals to this, then move to the next line. So we have a right-handed triangle pattern. The next problem we are going to do is multiplication tables from 1 to 5. We are going to print all the multiplication tables from 1 to 5, and the range will be from 1 to 10. Firstly, we will start with our outer loop, which is for I in range 1 to 6. Since we want print multiplication tables from 1 to 5, print table of whatever is our first variable, which is I. Then we will commence with our out inner loop for j in range. The range will be from 1 to 10, 1 to 11. Then we will print our multiplication table, which is print I multiplied by j is equals to I multiplied by j. Then we print this. So here we have our multiplication table. So this is the multiplication table of 1, then 2, then 3, then 4, and then 5. Now we learned how nested loops can be used to create patterns in multiplication tables. Pattern printing is a great way to strengthen your programming logic because it teaches you how loops work together. In the next and final practical section of the lecture, we will learn how to use control loops using break, continue, and pass. Welcome to the final practical section of today's lecture. So far, we have learned how to create loops using while and for, and how to use nested loops. But sometimes we don't want a loop to run normally. We may want it to stop, skip, or leave a block of code empty for future implementations. Python provides three special statements for this: break, continue, and pass. Firstly, we are going to start with the break statement. So for the very first code of break statement, what we are going to do, I'm going to tell a loop to print numbers from 1 to 11 but stop at 5. The program says stop at 5. Firstly, we will try to print the numbers from 1 to 11. We will iterate from 1 to 11, 1 to 10. For I in range 1 to say 11. In the for loop, we are going to define our condition, which is if I is equals to 5, then break. Then stop the loop, which means break. Then print. We're going to print I. So if you see, the loop goes from 1 to 4 only because it starts from 1, and when the I equals to 5, the break statement comes into play and stops the loop. This is the work of break statement. The loop starts normally. When I becomes 5, break immediately ends the loop. Number after 5s are never printed. The next problem which we have is search for a number. Firstly, I'm going to create a list of numbers. We will learn about list in the next section, in the next lecture. So don't worry about that. So this is the list of numbers. I want to search a number from. See, I want to search 45. So I will say for num in numbers. If the condition is if number is equals to 45, which or say search which is 45, print number found. Then break. So once the required number is found, there is no need to continue searching. So it prints number found. Or what we can also do, we can also print the numbers. If I use a print statement here, say print I, print num. See, as soon as we reached 45, it stopped the loop. Next problem which we are going to do is password verification. So in this, I will use a while loop. While our condition is true, password is equal to int. We will take input from the user. Input. Actually, we're going to take only input because I'm not going to use any integer values. Input. Password can also contain string values. enter password. And then we are going to start our condition, which is if password is equals to Python 123, then print access granted. And then we say break, else print password is incorrect. So what the loop will do, until we are entering a password here, it will check if the password is equals to Python 123, and if it is equal to 123, it will print access granted, and then we will stop the loop. But if this condition is not true, it will print password is incorrect. So for example, if I write any other number here, say I write 45678, it will print password is incorrect. And it's telling me, and the loop is not breaking because it's telling me to write it. The loop wants me to print the correct password, which is Python 123. Then it says access granted. The next part which we have is continue. Continue is exactly opposite of break statements. For example, for the very first code of continue, we want to skip 5, which means what I'm going to do, I'm going to print numbers from 1 to 10, but I don't want to print 5. So we will write the loop for I in range 1 to 10. The condition is if I is equals to 5, then skips it, which means continue. Continue, then at the end print I. Shift plus enter. You can see we have numbers from 1 to 10, but not 5. Only the current iteration 5 is skipped. The loop continues with the next problem which we are going to do is print odd numbers. Firstly, we will define our range for I in range. Say I want to print odd numbers in the range 1 to 10. My condition is if I, the condition to check odd and even is if I multiplies by 2, remainder 2 is equals to 0, which means which is the condition for even numbers, then continue. So this statement says if the number is even number, skip it and move to the next number. And at the end, print that particular number. So this will print 1359, 579, which are the odd numbers in the range 1 to 10. In the last part, what we are going to do, we are going to cover the pass statement. So paths usually don't perform any function. It actually skip or Python allows the empty block because of pass. Pass itself does nothing. For example, if I say age is equals to 20, and if I say if age is greater than equals to 18, then pass, which means if age is greater than 18, do nothing and print program continues. So this will print only program continues.
as as Python says, do nothing with this particular block of code because we have used pass here. So we are done with the lecture 4. Today we learned while loop, for loop, range function, nested loops, pattern printing, break, continue, and pass. Loops are one of the most important concepts in programming. I encourage you to practice every program from today's lecture and try to modify them to strengthen your understanding. In the lecture 5, we will move on to data structure, and the very first data structure which we are going to cover is list. So see you in the next lecture.